So, welcome everyone and good afternoon. So, today we'll learn about software aging and legacy system in our software maintenance course. So, here we can see that one cyclic model. We have already know about this model. So, this model. I think you can hear me.
Yes, we can hear you.
Yeah. Okay. Okay, in this cyclic model, we can see that 6 different key processes. So in this 6 different key processes, the first one is process implementation. So this is the actually in the beginning of software maintenance process, where we make actually planning, we set up the things, we prepare for training or other maintenance work, whether our system is ready for functioning or not. So in the next step, we have the problem and modification analysis. So once we get some modification request that we need to perform, then we actually analyze whether this change is viable or not. So after that request, if the request is accepted, then we go for the modification implementation. If our request or modification is approved, and in this step we need to test, we need to integrate the changes into the existing software, and then we have maintenance review or acceptance, whether these changes are accepted by the stakeholders or the customers. So, and this ensures actually this modification meet the requirement of the customers or stakeholders. Then we have 2 other steps that are migration and retirement. So if we want to move for a new platform or environment, maybe for a new operating systems, or another is retirement, maybe whether we need to decommission the project, or we need to kill the project. So these are the different steps so far we know from our software maintenance knowledge from the previous steps. That these are different types of software maintenance. Actually, these are based on the age of the software. The first one is when we are in the very initial stage. We just need to put support to the users. So how to manage this, handle this. Whenever it's a little bit moderate mature state, then we have some, we encounter or we experience for bug fixing. And when we actually turn it to the in the mature step, then we actually try to incorporate some other features or enhancement. And whenever we need to sometimes decline because our technology might be changed, our our requirement has been changed based on the latest interest of the target audience. And actually, this comes into the scene of this software aging thing. So software aging actually, like human software, also gets old, and not many users, they have, they do not care for revise it or re-engineer the work. But it is also true that some of the system has longer lifetime. And so in precise, if we say that software aging is the name is it's actually a phenomena. In this phenomena, whenever our software in a runtime or it's a runtime period, so it might have some failure. That means the failure might be increased. So a failure actually can take in the form of incurrent service, or might be some no service, and some other time say partial service. So in this time, actually, due to the software aging, we might encounter this type of failure. Actually, for hardware, it is very easy to see. It is easy to visible the failure, whether it is using a lot. But in the software, at the first sight, it's difficult that software has bug or not. So due to actually many aging related failure, software are nowadays perform actually experience the software faults. So now come the legacy system. Actually, we know that legacy system is an old method or technology, but still actually it's under use. So in the legacy system has might be various problem such as no more skilled manpower available. Even it has no up-to-date documentation. Even it might have huge documentation cost, even huge resource consumption. So these are the very big problems with the legacy system. Legacy system is a old software actually that is still useful, but it cannot be simply discarded because in the legacy system, this software is still running. So in the software, we have some experience or some validated knowledge in those software. The software might be old, but still those are in running state. So now come a little bit detailed discussion about this legacy system and software aging. According to Parnas, software aging is a program like people get old. We cannot prevent aging, but we can understand its causes. It takes steps to limit its effect, temporarily reverse some of the damage it has caused. Yeah, we can limit, but at the end of the day, the software actually is no more viable. So we lose our preoccupation with the first release, focus on the long-term health. So if we say precisely that this is a very big statement that we lose our preoccupation with the first release. It might happen when we launch the product. We are very much concentrate on the projects, but when it gets older, we do not pay any attention to those products. So the main idea is we are only obsessed with the release, but not about the sustainability of this product. For example, imagine a company release a mobile app. So their team puts all the effort into getting version 1. So it's a perfect design, tons of features, many things. So after the launch, the team actually stop investing on it. So this is how actually one software gets sold. So there are some other notions that software should not be old, because these softwares actually work in a way like mathematics work. So software is a mathematical product that does not decay with time. If a theorem actually correct 200 years ago, it still should be correct. Actually, these are not relevant because it is related with the people's requirement. So, and that's why it is not actually relevant that why software should get aged or it should not aged. So this is not relevant thing. So software does is nowadays software actually aging is gaining huge attention, because if we say that our surroundings, software has a very economic importance on our on every economy nowadays. Even many of the tech giants are actually has the capital as a software. So it's a very high time to give concentration with the software mm, aging technology. So the authors and owners of a new software product often look at the aging software with disdain. So, so if we say what is disdain, disdain means if we do not like anything. So if we do not like anything, we might have some preconception that, oh, it should be inferior, it is not that good. So some of the users or owners, they actually have a uh, very previous mindset that this software is not good because these are old software. Even only the software has been designed using today's language and technique. Yeah, some of us are very much convinced that yes, the software has designed with today's language and techniques. So this should be a very good software. But this is not always the case. So there are two main causes of software aging. One is called lack of movement, and another one is ignorant surgery. So lack of movement is aging caused by the failure of the product owners to modify it to meet changing requirements. So from the statement, we can understood that if the designer or owner of the software, if they do not pay attention to compatible their software with the modern technologies or time, if they do not want to improve the software, if they do not make some other versions or features, or they do not make maintenance sometimes. So this is actually due to the lack of movement. So another one is ignorance surgery. So aging caused by resultant of some other uh, not well deliberated change of the software. If we do not change software with well thought, this is called actually ignorance surgery. So one example could be given that lack of movement. For example, one e-commerce platform. So that platform still use say old payment provider support. So they do not have any say digital wallet like Apple Pay or Google Pay. So it could be because they are not interested to keep pace with the current technologies. Even might have that some website actually they do not adapt for mobile or tablet devices, because the front end has not been modernized, so leading to their poor user experience. So this could be one example for lack of movement. So one ignorance surgery. Yeah, some people might be want to fast their database query. So they certainly change their indexing mechanism. But when there is a huge transactions, but it doesn't actually work as they expected. So they did not actually, it understood that they did not test it well. So this type of change could be due to the ignorance surgery. And that's why people might be disinterested to use those software, and eventually software aging comes. Okay, so lack of movement, unless software is frequently updated, its user will become dissatisfied and change to a new product. There are some other very excellent product, but those are from 60s. But nobody will actually bother to use those. So, so it's very important. We should actually keep pace with the time and trends. So ignorance surgery, one must upgrade software to prevent aging, yes. And that's why we need to upgrade or perform maintenance. But changing software can causing aging too, because some people make changes, they do not necessarily understand why these changes are necessary. So, and that's why software structure degrades. As I give you example, that somebody thought that this indexing will make some good contribution, but eventually it became worse. So it could be one reason for software aging. After many such changes, nobody understand the software yet. The original designer actually no longer understand actually what he modified in the software, because there are so many iterations of changes. And those who made the modification still don't understand the software. So actually it's a mess. So changes take longer and introduce to new bugs. So and those bugs could make the system inconsistent and even inaccurate. So the cost of software failure. So and some are direct cost, some are indirect cost due to the software failure. So first one is inability to keep up and reduce performance and decreasing reliability. So we'll discuss those. So inability to keep up, that is, as software ages, it actually grows bigger because it always gain, like many new features request has came, and the different teams, they try to develop those, and those changes become more difficult as the size of the software increases. So customer actually want actually a new product that it has new features. So from here we can understand that so inability to keep up, that as software technology advances, so new operating system, hardware, or security standards arrives. But as software aging, they actually struggle to become compatible with the current system. Reduced performance as the size of the program grows it. So it happens that it actually decrease, or it reduce its performance. So performance decreased because the poor design, and resulted from that it cannot give service in term of sustainable way, that is that perform in long term way. So if it is it's a new product, if it has less age, definitely it will run faster, and it has less memory consumption. because it is designed in this way. So these are actually, that the cost of software failure. So another cost is that is decreasing reliability. So when the software actually fail several times, we definitely have less faith on those software. So many studies have shown that when we actually fix some bug, so it became more worse. So because we do not know that it will maybe trigger other bugs. So on average, whenever we one new error introduced, it actually it repaired. We need to repair more errors actually. So for decreasing reliability, we need to maybe abandon the project or maybe stop fixing bugs. So in a survey, it was found that so in a commercial product, it might have that um, at least it might have that it exceeds the 2000 actually unrepaired bugs it might happen. So reducing the cost of software using, we should, and so this long we have discussed that we have, if we have any software, cost. For the inability to keep up, we found that our cost might be that we need to increase development time, even customer dissatisfaction. For reduced performance, what might happen with a poor user experience because it is taking less time. Even we need to optimize the outdated code, and for decreasing reliability, so our brand reputation might be hampered, and we can lose the customer trust. So after discussing this cost, how can we reduce this cost actually? So, if we can reduce this cost, actually we can actually somehow refrain from software aging. So we should look far beyond the first release to the time when the product is old. So we should be very for insightful. We should foreseeing the very long that whenever we are releasing, what might be the challenge we should meet, and we should anticipate some of the challenge and just implement or not. We can put them in abstract way so that if it is necessary, we can reuse those. But inexperienced programmer, um, they're very much rush. They just release to the first version. But experienced programmer, they actually consider. So this first launching this could be beginning of a new era. Later they can. So responsible professional and organization realize that more work is invested between the time after the first successful launch and the first release then is required to get first successful run. So responsible and professional user, they actually invest more time after the first successful launch because they test it and they review it, even and they make some other release, some other versions. Uh, they perform regular maintenance. They documentize those changes. So this could be some preventive actions for restricting or limiting the software aging. So those are, we need to consider design for success.